Hi, I'm Dustin Griffin, Commercial and Technical Product Manager for Precision Laboratories. Today I'm in Southeast South Dakota in another one of our approved trials. Currently straddling the treated, which is here to my left, and the untreated is over here on the right. The only difference here is the seed zone. So it's seed zone versus the grower standard. So today we're going to walk through kind of a normal walkthrough of what I do on a day-to-day basis when I'm looking at trials. We're going to start off with a population count, then we're going to do some plant digs, and then we're going to use this penetrometer to look for compaction, and then we're going to take the corn plants that I do dig and we're going to go wash them off at the truck, and we're going to see if we can see any differences. Okay, so population counts. We make a nice big long mark so we don't get lost. I'm going to take 17.5 feet, so I'll take 17.5 steps. Then I will make another mark, and then I will count down the rows, how many, and we'll average out the 2 rows to get our population. So I'll be right back. All right, so the importance of why we do this is we've seen with SeedZone, there is a big importance of hastening the uniformity of emergence. In the studies that we've done, we see an increase in uniformity of emergence by about 40%. So in these colder environments like we are in Southeast South Dakota, that's a really, really big deal. They say that a plant that emerges 2 or more days after the first plant that comes up, that can be up to a 60% yield loss. So with our big increase in uniformity of emergence, that's a really big deal. So I just counted 34,000 and 33,000. So it's an average of 33,500 population in this field. This is in the untreated, and we'll go down and count the treated here next. Okay, so here we are on the treated side. On this row we had 35,000, and on this row we had 34,000. So that's an average of about 34,500. So like I said before, we do this to see if we have an increase in uniformity of emergence. As we know, that's a really, really big deal. So in this trial, it does seem that we have a little bit of a better uniformity of emergence. It's nothing crazy, but it does show that we do have a little bit of a better uniformity of emergence. Okay, let's go dig some plants. So I'm going to take 2 plants out of each side. One of the most important things that you can do, you want to pick the best representative for the row that you're in. You don't want to pick the biggest plants, you don't want to pick the littlest plants. You want to try and pick the best representation of what you're seeing in the field. All right, these are the treated. We'll make our way into the untreated, and then we'll do the penetrometer and look at compaction, and then we'll wash these roots off and see if we can see any differences. So I have a penetrometer here. It measures soil compaction. This one's set up for PSI, or pounds per square inch. I'm going to take probably about 5 samples in the population count that I took earlier and get an average of the PSI on this untreated side. Okay, so out of the 5, it ranged anywhere from 220 to 350 PSI. I would say that we definitely aren't in a very compacted area right now, but let's go see what it looks like in the treated. You can definitely tell this is a lot easier to put into the ground. Wow. So this was anywhere from 120 to my max that I had was 230. Definitely decreased compaction, which is going to allow for more nutrient availability, more nutrient flow, more water availability. I'm pretty impressed with that. Okay, so we have our roots washed off. So we have our untreated here on the right, and we have our treated here on the left. Some of the small differences that I do see is, there's not as many, feeder roots in the untreated. This plant looks actually really, really good. But there's maybe a little bit more consistency with the treated plants over here on this side. And that's pretty typical for what we see. We have a lot larger stalk diameter here on the treated compared to the untreated. Typically what I see, about 90% of the time, early season, really up until about V6 or about now, it's a pretty visual difference between treated versus untreated. A lot of times we're about a stage and a half ahead. With SeedZone, on average, we have a 5.8 bushel increase. I've done 143 large-scale field trials all across the United States, and we win those plots 85% of the time. I will definitely say that it does increase yield potential, right? So more roots, larger stalks, that's all, pulling nutrients and making bigger highways for once that switches over to the reproductive stages, about pumping those starches and pumping that yield into that corn.